Today we will discuss about strangeness. Why some particle we call strange particle? Because there were large number of particles whose created via strong interaction and decay through weak interaction. So we assign a quantum number for identifying these particles known as strangeness and denoted by S. So how we calculate strangeness? So we have Gallemann-Nishijima relation for finding strangeness, which is equals to Q equals to I3 plus B plus S by 2, where Q is charge on particle, I3 is third component of isospin, B is baryonic number, S is strangeness. I have discussed about third component of isospin in my previous video, and for know baryonic number, at first we have to know what is baryons. This already I have discussed in my first video, that which particle we call baryons. Once again I am reminding you all. I want to suggest to all that please very careful about this chart, because without this you can't learn particle physics. So what are baryons? Generally baryons are categorized into two categories. One is nucleons and second one is hyprions. In nucleons proton and neutron are included, and in hyprions we have sigma, cascade, lambda and omega. So for baryons, baryonic number equals to 1, and for antibaryons, baryonic number is -1, and for others, baryonic number equals to 0. And I want to discuss a trick with you all, that a third component of isospin either 1 by 2 or -1 by 2 for doublet. Doublet means like neutron, proton pair, etc. And I3 will be -1, 0 or 1 for triplet, like pi positive, pi negative and pi naught, which is make a triplet group. And I3 equals to 0 for singlet, like eta naught. Now take first example. For pi positive, we have Gallimann-Nishijima relation, that Q equals to I3 plus B plus S by 2. Because pi positive is triplet, so I3 will be equals to 1, and a pi positive not a baryons, so B equals to baryonic number equals to 0 for this. So put in Gallimann-Nishijima equation, Q equals to 1, I3 equals to 1, B equals to 0, S by 2. So S equals to 0 for pi positive. That means pi positive will not show strange behavior. Let's come to our second example, for pi negative. For pi negative, Q equals to -1, because pi negative is triplet, so third component of isospin equals to -1, and because pi positive is not a baryons particle, so B equals to baryonic number equals to 0 for that. So put in Gallimann-Nishijima equation, that Q equals to I3 plus B plus S by 2. So Q equals to -1, I3 equals to -1, baryonic number equals to 0 plus S by 2. So S equals to 0 for pi negative. So pi negative also is not a strange particle. Let's come to our third example, for chions. Because chi positive and chi naught comes under chions, so it is doublet. So let's take example of K positive. So I3 equals to 1 by 2 for K positive, and the charge in this equals to +1, and baryonic number equals to 0. So put in Gallimann-Nishijima equation, that Q equals to I3 plus B plus S by 2, because Q equals to 1 put here, I3 equals to 1 by 2 put here, and because chions is not under baryons, so B equals to also 0 plus S by 2. So after solving this, S equals to 1. for cations. So cations also show strange behavior. For eta naught, because eta naught is singlet, so third component of isospin will be equals to 0. Charge on eta equals to 0, because eta naught is not a baryons, so baryonic number will be equals to 0. Now put on Gallemann-Nishijima equation, that q equals to I3 plus b plus s by 2, because q equals to 0, I3 equals to 0, b equals to 0, s by 2, so s equals to 0 for eta naught. Let's come to our next example. In nucleons, take first example as proton. Because proton is doublet, so third component of isospin will be equals to 1 by 2, and the charge on proton equals to 1. Because proton is under baryon, so baryonic number will be equals to 1. So put in Gallemann-Nishijima equation, that q equals to I3 plus b plus s by 2, q equals to 1, I3 equals to 1 by 2, b equals to 1 plus s by 2. So s equals to 0 for proton. Let's take our last example for sigma. Because sigma is triplet, so take example of sigma positive. Charge on sigma positive equals to 1. Because it is triplet, so third component of isospin equals to 1. Because it come under baryons, so baryonic number will be equals to 1. So put in 1, that means Gallemann-Nishijima equation, that q equals to I3 plus b plus s by 2, q equals to 1, I3 equals to 1, b equals to 1. So after solving this, s is equals to minus 1. So for sigma positive, s will be minus 1.